energy, essentially the same, but so you know the two. So you can measure the AV or the PR interval very well in the inflow-outflow chart. In the ductus venosus, you can't. It's just the inflection of the curve here, the inflection of the curve there. This is not something we're going to be using. And if you look at the vena cava, very interestingly, not only you can recognize the onset very well, but you can see that the E wave and the A wave are in opposite direction. Remember, this is obtained in the ventricle, so E is filling into the same direction as A. So E and A are in the same direction in the ventricle, but when you look at the cava, let's assume that I'm in the entrance of the supravena cava into the atrium. Well, during E, I'm going to go drop into the atrium, into the ventricle, but during A, I'm going to be pushed back into the brain. So E and A are in opposite direction when you look at the cava, while they're in the same direction in the ventricle. So this is very useful because sometimes if you have a too fast heart rate, for instance, E and A will be merging in the ventricle, and you have a way to distinguish them. So this is useful to have. Now, if you want to measure the P to P interval, any place, if you want to measure the R to R interval, again, ventricle inflow outflow, and the cava is useful, but the ductus venosus is not useful for that. So these are the ones which we concentrate on. Now, where can you measure the PR interval? Well, to measure the PR interval, you need an era in which a signal can capture both a systolic event and a diastolic event at the same time. And for that, there are typically 4 locations. One, you can take a beam that goes into the left ventricle inflow outflow, and it goes into the ascending aorta, so you have this left inflow outflow. Or you can take an aorta and supravena cava, because the beam here can capture both at the same time, and you will have venous signal on one side, arterial signal on the other side. Or you can go anywhere in pulmonary circulation, because almost anywhere you'll have a pulmonary and aorta step side by side, and you'll be able to get the cheek flow. Now, sometimes you have babies that are really obstinate, and they have their arms around the chest, and they can't get anything, and then you can try to do the pull technique of going into the distal aorta and inferior cava. It's not quite as pretty. So this is what we're going to be looking at. So I'm running out of time. Let me give you just a few more images on that, and then we'll stop. If you have a baby whose heart rate is too fast, above 160 beats per minute, there will not be time for the passive filling of the ventricle. And then E and A are progressively going to merge, and you have a monophasic wave instead of a diphasic wave. Same thing happened with initial contraction. So here we have the supravena cava and aorta. You take a large sample, that are supravena cava here, and use one gauge, and then you can be tracing like this. And here are the capitals. You see V, E, and A. V, E, and A. And you see A being on the other side is easy to recognize. For the manual, you go for the gap, and you measure the gap over here. On the aortic sides, you have only the aortic side tracing, and so the PR interval is measured over here. Really a bit prep for time, but here again, another camel, you see V, E, and A measured over here. In the pulmonary vein, you just get an ugly sample, and I don't like that because it's so irregular. Just take a big sample like this, and then the camel in the pulmonary vein is not quite as spread. They have a lot of flat back. But again, you can see the V, E, and A, and so the gap here is the A, so you can measure the article this way. And then let me show you another one here, which is the left inflow outflow. This is the one you're most likely to start with. You take the balloon output, put your sample below the mitral valve, and then you get this. This is a tracing that has all the information, all the clicks that you want to look at. And the advantage is that you can measure this very early in the gestation. You can measure that already in the 9th week, and you you can see those measurements already in line 3. Now, I'm going to skip there because I don't have enough time. What I wanted to show you is that at whatever gestation age you measure this, whichever technique you measure it to, that PR interval has to be less than 150 milliseconds. If it's 140, you risk getting 3 days later. If it's above 150 milliseconds, then the patient most likely has either lupus or she has autoimmune disorder. And these are babies that can be treated prenatally, and these babies can be recovered. So unfortunately, I'm out of time here, but I really would like to urge you to download this lecture and go for it several times until you have all this information. It's very practical, very step-by-step. You will not become fetal echocardiologist after the lecture, but you will be able to do a lot of good for your patient. You will certainly be able to recognize what is a normal baby from a baby that needs to go to the tertiary center. And that is the most important thing you can do, because if someone doesn't detect a baby has an anomaly, no cardiologist will ever see that, and the baby will have to be treated after birth. Maybe they are transferred in an ambulance versus transferred in amniotic fluid don't have the same outcome. So I would urge you to go inside this lecture, and tomorrow we'll look at some of the cardiac. Thank you very much.